Hello, greetings. Testing, testing, one, two, three. We are reviewing some robots today. We're doing interviews and we are conducting.
Well, don't speak it. All right, mic check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. 1, 2, 3. 5, 6, 7, 8, 9, 10. Then I'm going to have the camera because that's about the distance. Not yet, the camera. 1, 2, 3. All right, go ahead.
Hello, greetings. One, two, three. Robotics event. We are going to review some robots and conduct some reviews and awesome stuff. Lots and lots and.
Hello, hello, hello. Can you hear me? Can you hear me? Hello, hello. Okay. Testing, testing. Okay. The robot jokes.
we going to make noise because we're too close?
Welcome to FAU, the College of Education, the Department of Curriculum Instruction Robotics Day. We are so excited that you are here and you're joining with us today. This is my colleague.
Hi, I'm Dr. Ann Musgrove. We're both in the Instructional Technology Department.
Yes, and I'm Dr. Victoria Brown. I'm within the same department, and you need to come back this way. You are good.
I don't know my right from my left. Your left.
So, as you can tell, we're not rehearsed. And I also would like to definitely thank the College of Education STEM Education Lab for sponsoring this event. And the founder was unable to be with us this moment, but hopefully you'll get to know him very soon, and we're very appreciative. The idea of live streaming was his, and we want to make sure that he gets the credit for that.
That would be Dr. David Kumar.
Oh. So anyway, do you have any wonderful, fantastic opening remarks, Dr. Musgrove?
We'll have a lot of fun. We'll try not to break anything.
Yes. So as we go through the day, we're going to have interviews of experts that will tell you about how to use the robotics in the classroom or how they're using robotics in the classroom. And then as students come into the room, they will be able to experience the different types of robots. Because we know you're online and you cannot put your hands on our wonderful, beautiful robots. We're going to make sure that we have demos of those robots go out to, by moving our camera around and going around, so you can go to the different stations that allow the students to interact with the robots. So you'll get a demo of the robots and some kind of explanations about how we can use robots in education. Any other ideas, Dr. Musgrove?
No, we're just really excited you're here, whether it be virtually or in person. And thanks for playing along with us.
Yes. So I think we're going to be shifting very soon. You'll see a nice little robot come up and say, hey, we're moving the cameras. So we will be back with you in just a moment.
Welcome back. I'm here with Nancy Rubin to answer a few questions about robotics and what she does. First of all, Nancy, can you share a little bit about yourself and what you do nowadays, your current role?
Sure. I'm a computer science teacher in Broward County at Cypress Run Education Center in Pompano Beach. And I teach middle school and high school computer science.
Middle school, interesting group. The people I know that teach middle school really like it, though. But it's not for everybody. How did you become interested in teaching with robots, other than they're cool and fun?
I joined a personal learning community through the district, and some of the folks who sponsored the community are going to be here later speaking. And that was how I got introduced to robotics, and all different kinds. And I'm actually showcasing the VEX robots today at my booth, and I'll do a little demonstration later.
Oh, that sounds great. So what do you use, what robots do you use in the classroom? What do you do with them?
So I had last year, and I'm getting some new ones, is I had the VEX 1, 2, 3, which are the round robots.
We'll see them later,
Okay.
won't we?
And I have, at my booth, I have the VEX IQ robots, which are actually kind of a little bit like Legos. So the students build the robots from parts, and then they learn how to program them. So that was really exciting, teaching them. They really enjoy the hands-on part of the building, and then running the robots is also fun.
What kind of goals do you have for your students? Are you working on computational thinking
Yes.
or?
Computational thinking, just teaching them how, because with robots especially, they don't always, everything doesn't always work the way that you think it's going to. So learning how to learn from your mistakes and
Oh, yeah.
not get frustrated, I think it's a great way for them to learn that skill.
Yes, I agree. You learn more sometimes when things don't work out the way you
Absolutely.
thought they were
Yeah.
going to.
And you have to think about the solution.
Yeah,
right? And,
yeah.
and iterate, lots
Yeah,
of iteration,
yep, yep.
which is very real world.
Yeah, it is. I think it was a bit like that driving here. Yeah,
Or parking.
yeah, that's true. That too. I assume that the kids in your classroom enjoy this? This is something they like doing?
They do like it very much, and we actually did like a challenge. We did a challenge for I had 2 middle school classes, and they each built robots, and then we had an afternoon kind of like this, dedicated just to robotics, and we ordered pizza, and they had contests, and we had some challenges that they engaged in, and they really liked that.
Yeah, well,
With prizes.
no, even better, even better. So what would you like to share about our group here, which are mostly pre-service teachers, about teaching with robots?
It's just so much fun. I didn't really know what I was like. Don't worry. I mean, your kids may know more than you do, and don't let that scare you. I didn't really know what I was doing. I kind of just jumped in with both feet. And there's a lot of resources online, especially for the different types of robots that you'll see here today. And just go with the flow. I mean, just learn with your students. I think that's the best advice that I can give you.
Yeah, and don't be afraid to make mistakes.
Absolutely. Right? Yeah.
Any questions from the audience? Or should I say the students? This isn't really showbiz. Feel free to ask a question online. We're monitoring that. That's the virtual we.
If not, I'm going to go get ready for my demonstration and run my robots.
Okay,
All right. Thanks, Ann.
thank you. Great to see you.
You as well.
Here's a question done. Who gives me, you're going to give me the,
To take care of. This event is being recorded and will be available online following the live event. We will have time for questions, so we have a person who's monitoring that, and that's what we were just discussing. So please use your Zoom chat to submit questions to our moderator. Be aware that all attendees that choose to use the chat features to participate in today's live stream event will have their name, comment, and questions displayed on the chat. And other attendees that are online will be able to see that information. The chat's content, however, will not be a part of the recorded version. So you'll only be your information will only be shared with those that are on the Zoom chat right at this moment. The second thing we really need you to do, if you are an FAU student and you're receiving credit for attending this event, there is a sign-up sheet URL that is going to be posted in the chat, and please click on that URL and sign in so that way we know you attended the live event or the live stream event so we can give you credit. Then before you leave our live event, we would definitely appreciate if you would take the exit survey as well so that we can see how the live event went from your perspective. So we're very excited about that. There's new people walking in the room. I think we're going to have a few more students who are going to start interacting with our robots. So we're super excited that you are with us today, and thank you so much for joining us. We're going to go ahead and go to our little travel screenshot, and we'll be back in a few moments to demonstrate the mini Spiro. Here to I'm here to demo the mini Spiro. You can see Mini means Mini. He's a very, very tiny little robot. But what we do with Mini, is the mini robot, is we actually use it to learn how to use a tablet as a joystick. So if you know anything about robots, there's a lot of different aspects to a robot. Some robots we drive, and we actually use joysticks, tablets, all kinds of devices in order to guide that robot going to go wherever it might want to go. Kids love mini Spiro. Spiro can, number one, because it's a little bit of a challenge. If you look at Spiro, he's weighted. So as you try to drive him, he's going to wobble, he's going to go different places. And so they have to actually figure out how to manage that driving capacity as it goes. Now, the app is really simple, as you can see. This is our joystick, and it's the app can only be downloaded onto a tablet. So you can use a Apple tablet or you can use an Android tablet. This is an Android tablet, and very simple to use. And as I drag my finger around the actual window there, Mini Spiro is trying to work really hard while I've got him holding in my hand, will then go the direction I want it to go. So I'm going to put Mini Spiro on our challenge mat. I'm going to warn you, I am not the best at driving Mini Spiro, but I'm going to see if I can make Mini Spiro go through my maze. Whoops, going backwards. Go the other way. Oh, he's not going where I want him to go at. So it takes a little bit of work and time to figure out how to drive the little Mini Spiro. So I know I've had people come to Robotics Day in the past. Woo, there we go. I got him into the maze. There he goes. And I got him out of the maze. So the nice thing about the mini Sparrow set is you can see that I have these different little pieces on the floor. We have arches, we have fencing. Actually comes with bowling balls and other things. So the students can actually create their own mazes, their own challenges for driving their Sparrow. Now, Mini Sparrow also is part of a larger group. So we are doing the play version here in the robotics room because we have other robots that will teach other aspects of robotics. But you can actually program Mini Sparrow to move around your challenge board as well. And you'll see more of that with Dash when we get to the Dash robots. Then they're programmed to actually move around. Mini Sparrow will do the same thing. It just is a different program. There's many different apps that you can use with Sparrow. And just as you heard Dr. Rubin talk about her use of robotics in her classroom, these products all have apps. So you don't have to be a robotics expert in order to use the robots in your room. The people who put the apps together are those experts. So it literally becomes plug and play for you as you go into navigating and using these robotics in your classroom. Now, one of the things people often ask is, how can I incorporate this into my actual class in other ways as far as curriculum? And the really cool thing you can do with that is actually build, if you have a story line that maybe you're working with stories or reading a book, you can actually design your challenge board to match a part of that story and have the students navigate the story through with the robot. We can also include numbers, all types of curriculum, and also making sure that the kids have some opportunity as well to create their own challenges and be very creative. And you'll see when you get to the Dash robots, they actually designed a world in which the robots will navigate. So pretty much your imagination, the kids' imagination, is what is the limit of how you can incorporate these little Sparrow robots. So I hope you enjoyed our demo of Mini Sparrow, and hopefully you get a chance to experiment with Mini Sparrow in the future.
Hi, I'm Dr. Ann Musgrove, and I'm here to talk to Ontaria. Ontaria may be a student of ours soon, but right now her major gig is running a nonprofit.
Yes. So I run a nonprofit called the Dentist Project. We've been around since 2012, and we serve underserved communities and low-income children, and we expose them to STEM. So I
Do you
am.
go to them?
I go to them. So we
Okay.
do have outreach programs. I started off in Fort Lauderdale at a science museum, and
The Science Museum?
the science museum.
That would be mods.
That would be mods. So actually, I used to spend the night in the museum.
Oh,
Yeah. So we would create programs, and the kids and the families would come out and spend the night in the museums. Wonderful programs. So I am a Moz alumni, and they inspired me to start the nonprofit, the Dentist Project. And we were doing projects like this that we're doing today with Lego Mindstorms and coding and building and things like that. And we've been doing that for the last 11 years. So we're super proud of that.
that does sound really wonderful.
Yes,
There's nothing
yes.
like STEM events for the people that don't get them all the time.
Absolutely.
Yeah.
Absolutely. Absolutely. So that is our purpose, to go into the areas where the kids can afford to do the immersive programs like at the museum and things like that.
Yeah.
They're still able to have those experiences because we know that minorities and women are vastly underrepresented in STEM. So we want to spark that interest so we can see those numbers go up.
Yeah, and I bet you get a lot of interest, and that does
Absolutely.
happen to them. What did you
Absolutely.
bring today to play with? I know you probably play with a lot of different things.
Yes, yes,
What are
yes.
your favorite robots, by the way?
So I love the Legos because first off, they're very easy to maneuver, to build, and to code. So
And
that's
most
what
of
we're
us
doing.
know Legos.
Yeah,
Even
absolutely.
Even if we just stepped on them on the way across the room before.
Absolutely, absolutely. So that's what we're doing here today.
So you want to show us a little bit of that?
Absolutely. So I'm going to go on this side. So one thing that I love about Lego education is everything is kind of mapped out for you. So you have all of your pieces here to build, and they coincide here. So it's easy to find the pieces because we know back in the day, stepping on all of those pieces. So everything the bricks have their own compartments here. And I like to start off with the children with something very similar.
And I noticed you have the educational tool we all use, Ziplocs.
Ziplocs. Absolutely. So the difference that Lego Education is doing now is everything is on the computer. So before we would have the books and you lose the books, but not anymore. So everything is designed on the computer. And today we were going to start building like really simple. So as you can see, they give you the pieces, they coincide with the compartments, and then you build one by one, the same way you would do any Lego project. So, and this is a very simple one.
So do you build it first on the screen and then connect it to your base object there?
So you would, well, actually you're just going step by step. So we didn't have anything built right here. So you're just building it step by step. And then at the end, in this particular project, they're adding
The motor,
the motor
the
to
thing
it.
that'll make it move.
Absolutely. And this one actually makes it light up. So in this particular situation. So here we would have built that. And then after we do the building, then we do the programming. All right. So in this case, everything is
Is it using Wi-Fi or Bluetooth?
it looks like it's using Wi-Fi.
Okay.
And here is where we code. And as you can see, like it just said, it gives you very simple instructions. In this particular kit, the children can be as young as 7 and design these programs. So here, we are just simply so you just slide, move it up. And in this case, it's done by a color pattern, which here they're numbered. So if I want my robot to be pink, then I'll put 1. If I want it to be green, I will put 5. And it's just that simple. The instructions are here as well that tells you how to number it. And then you just simply hit the play button. And if we were connected, then this brick will light up to be that. So it's pretty simple.
It's kind of like visual block coding.
Absolutely.
Okay. Can you see the code behind it if you wanted to?
Not in this particular
Okay,
program.
that's fine. If it's for young kids, that's not very important, I don't think.
Absolutely. And they have several different projects. So we were over here practicing some of the projects, and I wanted to, if we can, just show you guys some of those. Hold on 1 second here. Where it tells us about all of the pieces. We have our motors and our lights. You can also have it play music. Lots of different things going on here. You can have text. And all of this, the children could use the visuals and pull in the bricks in. Yes, absolutely. Thank you. Thank you. So as you can see, thank you so much.
Takes a village, always, especially with tech.
Yes. So, and this one was really cool too. So they can do the cooling fan and different projects depending on the difficulty. So we start very simple and then work our way up. And that's what we're doing here today, and we're pretty excited about that. Lego has some other ones that are a little bit more advanced for your older, your middle schoolers, your high schoolers, and then you have your competitions and all different types of things. So it's so much to do, so easy for our educators to bring this into the classroom or into informal learning in your after-school care programs and things like that.
Ontaria, if somebody wanted to get in touch with you to get contact about your nonprofit, how would they do that?
Stop by our website. We're at dennisproject.org.
Is it, spell it for me.
It is DENNIS
Okay.
project.org. All right, or you can reach us at 305-452-0881, and we will be happy to tell you all about it.
Thank you.
Thank you, and thank you for having us.
Oh, thanks for playing with us. And so far, we haven't broken anything.
Thank you.
Hey, welcome back to Robotics Day. I am here with Belinda from Broward Schools. Can you introduce yourself and tell us, a little bit about what you do?
Sure. My name is Belinda Beckford, and I am an instructional facilitator for over 241 schools here in Broward County District. I support programs in robotics, AI, drones, esports, gaming, and Minecraft, and a number of other items that are on my list that I can't remember right now.
Well, it sounds to me like you've got quite a lot to remember.
Yes.
I hope it's a fun job.
It is a fun job. I get to interact with teachers and students. We have events across the district with different programs. So, like coming up, we have our robotics event at Miramar Regional Park, and it's going to be over 32 schools that will be competing.
Ah, did you know Johnny Depp went to Miramar High?
I did not know
Oh,
that.
okay. He didn't graduate. Why do you think it's important to teach robotics in the classroom?
It's very important because it helps students become more creative. They use computational thinking, they use spatial reasoning, and they're able to just engage with other students and collaborate. And they learn about the engineering design process, which will take them very far as education and career.
Yeah, I know computational thinking is now the big buzz. They say we
Yes.
all use it every day in everything we do.
Yes.
And it's time that we recognize that problem solving that we have to
Yes.
go through on a daily basis, doing a lot of different things. How do you integrate it into a secondary classroom? Do you do a lot with secondary classrooms?
Yes. So the way you integrate is you have your teachers that are interested.
Yeah, that helps.
That helps. And we have workshops to align with their curriculum. So it may be a science teacher, it may be a debate teacher, it may be a Spanish teacher. So we take what I just talked about, computational
Yeah.
thinking, and use it as a prototype for what they might want to do. It might be a project. So it might be a debate teacher want assistive tutor for a student. So we can have students create a prototype that might help them in the future for one of these courses. Or it might be something that might be a real world problem that students want to create for that particular subject area.
Yeah, that all sounds like great stuff. It sounds like your students would be very motivated to learn these things, and that learning might feel a lot like play sometimes.
Yes.
Yeah, that always helps. What is Broward County School District doing in general about incorporating all of these technology tools?
Like I said, we have workshops for teachers that are interested in bringing robotics to their schools. If you want to be a robotics teacher on record, we have programs and certifications that you can go through to be the robotics teacher on record. And then there's after-school clubs that teachers can get involved with as well.
That's one of the things I like. I'm in instructional technology at FAU, and one of the things I like about being in instructional technology is that you can play with all the different curriculum areas.
Yes.
Like you were saying, you're not pigeonholed into something. If you want to do something with literacy, you can do something with a book in robotics.
Right.
If you want to do something with science, obviously that's a fit that somebody would think. But you can do a lot of different things if you're playing with technology.
Yes.
What's it? I think you covered some of this, but what is required to become a teacher of robotics and coding in the district?
So there's different certifications. So if you want to be a robotics teacher, there's an engineering certification as well as a technology certification that they could take to be that teacher on record. If they would just want to not go that route, we work with CTACE, which is our careers department, who has a Broward County certification that they can take as well to become that teacher. Or you can be out of field and teach robotics.
Again, it fits with almost any curriculum
Yes.
that you're doing.
That is correct.
Sometimes you got to be a little creative, but it's there.
Yes.
Yeah. And I think that's about it for Belinda.
All right.
Thank you for coming.
You're
Thanks.
welcome.
Hi, so we're going to go ahead and program our robot. We use block coding, so if you're familiar with Scratch, this looks like something you've seen before. So we're going to go ahead and configure the robot, and we program it here. And we connect from the brain to the robot brain. And then we're going to go ahead and send the code directly to the robot. So we'll go ahead and download it from here to the robot. This the students built themselves like Lego. So first they actually have to build the robot before they get to program it. And now we're going to see how good their program really is, if it runs. So let's check it out. So now it's calibrating itself, and we have the light sensor. You can see the light sensor, and it's going to turn, go in the other direction, pick up speed a little bit. And there we go. Our first program. And we do a lot of different challenges with the students, so they have different curriculum that they can use. They can, we block off some squares and they have to program the robot to drive around, or we put up obstacles. I have some obstacles, and they can program the robot to knock the obstacles over. Yeah, just a lot of fun. If they like Legos, they're going to love Vex robots.
inputs, being able to use wires to make things a little farther away, and then what our output is, what we're actually going to see at the very end. So let's go ahead and get started with doing a little bit of playing. So this is our power, and it also could run off of a 9-volt battery, and we have ours instead plugged into the wall. So this is all set up so it adjusts and can be connected just using magnets. So each one of these has magnets in it. So I'm going to show you kind of what to expect. So this is a very simple one. I have power. Right direction. And you can see that the power through. So the circuit is complete and it's lighting the light bulb. So I can do other things. What if I use a button? We all have buttons that we use to turn things on and off. So let's see what happens. Well, the light bulb is not lit right now, but if I push the button, the light bulb is lighted. And so that's a way for us to be able to see that we're opening the circuit and the electricity is flowing through. And think about things that you use that have buttons. Any of you play video games? Oh yes, lots of buttons. So we can just take any of these inputs and we can go ahead and use other things here. So maybe we want to use a slide dimmer switch. Remember I said magnets? You saw it jump. So it went right to magnets. And let's see if we can do something here. And right now it's turned off, but if I slide my dimmer switch, you'll see that the light gradually gets brighter and brighter. So this is kind of neat to be able to see. Some other things that we can do. Well, one of them is I just popped in a light. And this light is what color now? Looks like it's blue. But I have a handy dandy screwdriver, and so I can adjust my little screw down here and adjust the color. And I've got a red, a green, and a blue area here that I can change things. So that one looks like it's more green now. And let's see if I adjust the green, if it will take it back down to red. Kind of hard to hold a microphone and a screwdriver, but we'll try our best. So I have that one all the way down, and let's see. But at least you're getting the idea of how this can work. Let me get rid of this light. Again, I can use my slider right here to be able to manipulate things. So what else do I have? This one is a temperature sensor. So depending upon how hot or how cold it gets, it's going to make a difference with my output, one of my green outputs. I have things like, this one is a light sensor, and I could actually put my finger over to this, and I can say, hey, when it's very dark or when it's very light, I have two different modes on this that I can switch around, then it's going to be able to pick that up. And then I also have this right here is a sensitivity. So it determines how sensitive it is, very or just a little. Another one of my inputs is a pulse. And the light ends up being the easiest one to be able to see. But you can see I've got it pulsing now. And now, as I adjust here, you'll see that the pulse becomes steady versus pulsing very, very quickly or being very slow to pulse. So lots of ways that I can take a look. And a lot of these things have applications in real life. Things in our household, things in our cars. This type of thing right here is fun. I have to match this up carefully. This is a good time to use a wire. Move things so that they're a little further away and a little bit easier to use. So let me see if I can do this. And now my wheel is moving. And so I can take a look at that. I could also change this a little. Oops, still attached. Let's try that. I could a good on-off switch. Okay, now I have this on with a button, and we know that I have to push the button in order for the action to happen. So here I am, pushing the button, and now you can actually see that the wheel is moving. If I take my hand off the button, then it stops moving. And so this just shows us what we can do with electricity, how we can use electricity, and how it can power different things in different ways. All very real-life applications. So I just showed you some basic things, but again, you could take things and string them together. And then you can go ahead and try to, let me just see if I do this. Okay, now I've got two different things on the same circuit. I'm running this and I'm running this. Notice that I'm running this one a little separately. It has its own separate control. I can add the input here. I'm adjusting just this light with the pulse, and I'm adjusting the dimmer for this light over here. And look at, because it's linked in and the pulse comes first, it is also pulsing. Remember before, I didn't have the pulse in there? And so now you can see how this all affects, one thing will affect another. So, pretty fun. You could spend hours here, and there are bigger pieces, additional pieces you could use instead of doing this. We could you probably can't really tell, but that is a fan that's running. And so I could change this. I'm using my dimmer. See how the fan has stopped running? You can see right down here, it stopped. When I use the switch here, it's able to make it run at different speeds. Just a lot of good things. So most of you hopefully have fans at home or in your car. This is how it works. Let me know if you've got questions.
Okay. Hi. We're back at Robotics Day. I am Dr. Ann Musgrove, an instructional technology professor. And I'm here to introduce you to some more robotics people. First of all, Erica, introduce yourself.
Hi, my name is Erica Cheva, and I am a high school engineering teacher at Olympic Heights in Boca Raton, Florida. Also working on my PhD at FAU in curriculum instruction.
All right. But I haven't had you in class yet.
No, I've evaded many professors.
Okay. So what's it like teaching in high school with robotics?
I absolutely love teaching high school engineering. It's exciting to see the kids get to come up with their ideas, build things, make their imagination become a reality. I just wish there were more students who were involved and knew about some of these programs that are available at different schools in different counties. And also, you know, one of the reasons I wanted to come today was to kind of see different things that could maybe extend that high schoolers could reach out to some elementary or middle school kids to support, to spark that interest for other individuals.
We actually have a STEM Girls Club that we're starting to work with at one of the local middle schools. So I'd like to tell you some more about that sometime in case you have some interest in that. And Noelle, please introduce yourself.
My name is Noelle Guay. I am actually a 4-H youth development professional. So I lead the 4-H program in Palm Beach County. I'm also a CNI PhD student. I'm in my second year. And I work with youth ages 5 to 18 across a number of different project areas, but my main focus is STEM and robotics. So I had to come and check out what was going on, what FAU was doing, and I've seen some really cool things so far.
Yeah. Are there any things that you see that you use in your?
Yeah, so we actually just got the Spheros, so I'm actually excited to play with those. We work with the Dash Robotics, so that's kind of our second step tier in teaching coding, and we've done the Lego EV3s as well. So it's a couple familiar things, a couple new things. I'm actually really excited to check out the microbits, and then there's another robotics challenge kit as well that I'm excited to check out.
Nice. You work with the young ones and the old ones?
Yeah, so it's actually ages 5 to 18.
Yeah,
so
that's pretty much everybody
it
in
is pretty
the
much
K-12.
everybody. But it's nice. We do a lot of like team leadership, and so the teens mentor down, we mentor up. You know, so it's a nice, nice way to kind of give everyone sort of hands-on experience. They can find their spark for whether it's actually robotics, whether it's education. So they also learn some of those soft skills like communication and teamwork and patience and working with younger youth. So it's actually it's kind of fun. Definitely challenging sometimes, especially with robotics, trying to bring it to, you know, elementary school kids and then to high school kids. But it also keeps it dynamic and fun.
Yeah, I would think so. I have not worked with Dash with anybody older than second grade. So when I first learned it, the teacher that taught me said, "Oh, this one's easy." You know, it's like, that's what I want. I want the easy one.
I liked him too. He's also very personable because he talks and he moves and he blinks, and the kids really, you know, engage with it. And so it's been pretty fun for us as well.
Have you guys worked with any drones? We had someone flying one around here just a few minutes ago. It was a cute little drone. I don't want to give anybody the wrong idea.
A little bit. I do run an aerospace engineering course.
Oh, okay.
But we don't do quadcopters, of course. But
Yeah.
it's kind of difficult to get kids to be consistent in after-school clubs.
Oh,
Especially at
okay.
the high school level. They have jobs, they have athletics, and you know, we find that it's kind of like the same students who are really being drawn towards that STEM extracurricular. It's hard to split up the time.
Yes, I imagine. I have a. He's having problems hearing you. He wants you to
wants
talk
me to go
louder.
closer?
Yes.
He wants you to love
Just
your
hold
mic.
it. Okay.
Yeah. I have a friend recently who had to have a roof inspection of her tile roof to get some type of extra good deal on her insurance. And they sent up a drone to look at her roof. And I thought, what a great idea. I didn't even think that you know, of that, but it makes a lot of sense, a lot safer than, you know, climbing up on your roof.
Well, even connecting drones and sea perch, which is the underwater unmanned remote vehicle. I've got some students who are considering that for their science and engineering fair, looking at building different attachments and being able to go check out coral reefs and things like that. So definitely the unmanned technologies are very emergent and in a lot of different fields.
Yeah.
I've seen them use them on whale watches.
Oh,
So,
yeah.
you know, you're out in the boat and then they have the drone up and they can tell where the whales are likely to be.
We can survey more, like, larger areas, I bet,
Yeah.
easily.
Yeah, instead of just hanging in a boat,
boat,
and
hoping
dropping
you
a
see her.
microphone to hear if you can hear anything.
Yeah, that's very interesting.
That reminds me, even one of my aerospace girls, she's a senior, and she's looking at the Naval Academy for college, and they introduced her to all the things they're doing with drones now too. So she always wanted to be a pilot, and now she's like, computer science and coding and be able to control some of the things and get information that you wouldn't normally see through drones. It really opened her eyes to that.
And no air sickness, maybe.
Yeah. Yes. Yes.
No.
So who do you like working best with? The little ones, the big ones, or it just depends completely on the kid?
It definitely depends on the kids and the activity. So, of course, I have my favorite activity. So, any age with anything STEM related, I'm usually a happy camper. I do a marine science camp, which is always fun, and we have used sea perch to explore. But yeah, I think if I had to pick, I like the teens. I like the teens. They're very. I feel like I'm making a difference with them. You know, there's definitely that connection there. So, I enjoy them. We're actually just starting a farm bot as well. So it's like an unmanned farm robot that they're going to assemble, and it monitors, it irrigates, etc. So that's the next thing we're bringing for the teens too. So trying new and exciting robotics things. So hopefully add to ag too.
Yeah.
Yeah.
Maybe it'll keep us from killing our house plants.
Wouldn't that be good? I know I could use that. I don't have a green thumb at all. At all. Poor things.
Gotta plant natives.
Yes, exactly. I want to grow here.
Well, thank you both for being here.
Oh, thanks for holding this
And,
event.
you should get some chance to play with some new things, as well as maybe show us a few tricks with the ones that you're used to.
I'm excited to fly the drone.
Well, it's right over there.
Yeah, that's where I'm headed.
Thanks again.
Awesome. Thank you, Dr. Musgrove.
All right, I'm here with Natalia, and we're playing with this Dash robot over here, which is an educational robot that we can make drive just for fun all around the solar system. We're just playing with it and doing silly things, trying to get it to drive, light up, dance, and do different things. Right, Natalia? Yeah. So we've been building this program here, and what were some of the things that you liked most about it? Did you like that you could make it do a gobble gobble? Yeah. So do you want to show us how it starts? How do you make it go? Good. So press the green button. So you want to try it? Great job. We pick some different things like light up and make different sounds. So he's just driving off, and we were experimenting and just picking different things just to go driving all around and make him move around the solar system because she wanted to drive. So we picked drive, and he's driving forward, driving backward, lighting up. Do you think that's fun? Yeah, okay. Great job. Is there anything in this program that you might like to take away? What part? What color? This last one here? All right, so I'm going to take it off. And how do I get rid of it? Where do I throw it? In the trash. Okay, so I'm going to just grab that one. I don't want to get it all. And there it goes. What would you like to do instead? Would you like to make a sound? Instead, is there something else you'd like to do, have the robot do that you want to program it to do? Maybe a sound? Yeah? Okay. So how about that one? You like that one, okay. And then what do I do with it? How do I put it on the program? Where do I put it? Right there, yeah. So grab it. And just try to drag it. Oops, I just moved one. Click. Now it's on there. Do you want to press it again to see how it works? Go for it. Coming back. All right. Great job. Have a high five? Yeah.
All right.
Hello, this is Dr. Brown. Hello, this is Dr. Brown, and I'm interviewing some students who are here at the Broward campus who are taking classes with us, and we're very excited to hear from them. Although they're not teacher educators, they did have some really good insights that I thought you would appreciate with sharing with us. So, can you please introduce yourself?
Hi, I'm Lan Xitao. I'm a student at FAU Environmental Education major.
Okay.
Hi, my name is Albert Jimenez. I'm a computer science major from Broward College, studying computer science, computer programming, and analysis.
So they have joined us here at Robotics Day, and I was talking to them as I was circulating through the room. And I thought, wanted to have their impressions about Robotics Day and what did it mean to them. So they had some very good insights to share. So what do you think about our robots?
I think it's definitely a lot better than when I was growing up. A lot of the things are better designed. So I don't remember what's that.
The little bits?
Yeah, the little bits. So they're connected by a magnet instead of wires, which that literally makes the things last way longer than I remember. With the one I have, and the Lego ones was pretty impressive because it just kind of helps students to understand the whole logic of each module or do different functions and stuff. So it's direct.
One of our conversations that we had, it was about learning about circuitry in elementary school. And what did you think about the comparison of the circuitry kits that you learned in the past versus using the little bits that you're using today?
Well, the ones we had before, we mostly just hope it works. It could be brand new, but it still might not work.
I also think the really cool thing about the little bit is it teaches you about a circuitry, and actually you turn on a light, you actually turn on a fan, you can actually make a car go. So it literally shows you what's behind the scenes, right, of what your electronics look like. And how do they work? And the other thing I kind of like about it is it actually looks like a circuit board.
Yeah.
I get our computer science guy here. Well, that's for that. So introduce yourself.
Yeah.
Please, Albert.
So my name is again Albert Jimenez. I'm a computer science major, and this is my first robotics event that I've ever been to. I have been exposed more to hackathons and things like that, but it's very nice to come and see. That FAU is kind of showing robotics, and what I'm seeing this is as what can coding create? Because all of these things that I'm witnessing right now, there's all coding being done in behind the scenes, and it's like, oh, okay, it gives me, just ideas start coming to my head is, oh, if I'm learning how to do all of these coding things in school, I can actually start implementing all of this code in something that can benefit, even kids. Because I saw the Legos We Do It 2.0, and that blew my mind because I remember playing with Legos as a young kid, and those are tiny Legos. I was playing with huge Legos because I guess they thought I was blind, but none of them had motors. None of them were really interactive like that. And I think, even though these lists we do it too, 0.0 is a little more advanced, it might jumpstart a very young student at that, to kind of spark their curiosity on computer science in general.
One of the questions I did ask you before I brought you to the table, and you had very good insight on that as well. I would say, what if you had these types of programs? Would it have jump-started your coding interest, and would it make it easier today now that you're at the university level and doing coding? Yeah,
I agree with that 100%. That is something that I think my school, at least I went to elementary, middle school, high school here in Broward County in Florida, and that's something that they kind of lacked a little bit in, but it's something that I wish they had, because I would be in a very, very different position now. I would be much more ahead than where I currently am if I was just a little more exposed to, you know, the things that were out there that they were, because I mean, computer science is relatively new, but it was out there while I was in elementary school. It's not like it didn't exist.
Right.
It was just in the works, but there was still enough to kind of expose us to a little more of that. But nowadays, it's taken off to an exponential rate, where it's like every school can adapt into their curriculum some sort of computer science or robotics program.
Yeah. And I think it would have made it easier in your coursework if you had the basic understanding of what coding did and how it worked and how to think like a computer scientist. And I think, and that's what these little educational programs are doing. So it would have better prepared you for where you are right now.
Yeah, definitely.
Yeah.
Definitely.
I heard that same from you, though, that you thought that it would better prepare you for your career choice.
Yeah, because I used to work in tech for 3 years, and then I do feel like so some of the little bits thing, we are even the connection we are not using it until like last year with our product, and just that connection of like if we want testing with actual product, like that's a really good design. Like, and people probably not think of that if they never seen that before, because mostly when we are trying to test it, people just thought about, oh, I might just buy a wire instead of, oh, I might buy those like magnet connection dots. And also like, this is something like I don't even know that those dots are actually with a USB connection. I did not know that until last year. I was like, why all the things that work, they just directly connect, and that connects to the power. And then my colleague was like, oh, that's USB. I was like, that would make a lot of sense. Like my brain's just like, wow. Yes. So like a lot of things, like I think like if kids know about that when they're at a young age, it just becomes natural for them. So which is really important for them to have that.
Right, so it really doesn't matter what career field they're thinking about. It's helpful to know the basics behind coding. Yeah, because you're going to be communicating with a computer or an AI or even artificial intelligence in the future. So if you understand how that piece of equipment works, it's easier to communicate with it. Yeah, so it's a very valuable skill to have. Well, thank you so much for sharing your insights with us and about Robotics Day and how it's impacted you and the way you're thinking about your career future and how it could have helped you as you were in school. I just want to remind you very quickly that if you're online, that the session is being recorded. Your chat can be seen by anyone who's in the chat room. However, when we go to post this afterwards, all those chat comments will not be part of the recorded version. And if you are an FAU student, please send an email to Dr. Brown at V as in Victoria, Brown as in color, 22 at fau.edu, so we can make sure that you get credit for attending this particular session on live for your classes. And then I'll also send you an exit survey to learn more about how you're seeing and feeling about our live stream event. Thank you for being with us, and we'll be back with you shortly.
Hey everybody, my name is James Nance. I'm a STEM instructor at the Kane Institute for Advanced Technologies at A.D. Henderson University Lab School and FAU High on the campus of FAU's Boca Campus. So I brought some of the things that I use in my classroom today. I really focus a lot on hands-on experiences for students as I teach them about STEM and technology and try to infuse subjects across the curriculum. So what I have over here is these are examples of Sea-Perch robots. Sea-Perch is an Office of Naval Research robotics program for middle and high school students where they construct a robot out of PVC. They prepare and waterproof their motors, and this is all driven by through a tether with a control box that the students actually solder together and a battery which stays on deck. Students are free to redesign the stock robot under a $25 budget and race this robot in both an obstacle course and in a mission course where they have to manipulate various objects underwater to simulate using a real ROV in the field. So we see a couple different examples here. This is pretty much a stock robot prepared as per the instructions. And these are examples of robots of an advanced team who've been at it for about 3 years now. And they were actually able to go from a 700-gram frame down to a sub-70-gram frame, but still using the same propulsion motors and still driving the robot through the same tether with the same controls. But this is a really fantastic competition which involves a technical report, video elements, as well as the building and the operating of the ROVs. The next section of what I brought is based on the microbit single board computer. So this is a low cost computer, runs only about $20, $25. Matter of fact, every 7th grader in the UK receives one of these as a way to be introduced to computer science. So I actually use these with my 6th grade students. I introduce them to computer science concepts and block coding with just the chip itself. It's really a lot of fun for them. It's got 2 button inputs as well as some capacitive inputs as well. We've got a 25 LED matrix on here. There's a accelerometer as well as gyro on board, light sensor, and the new models even have a sound sensor and speaker on board as well. So I like to teach students to incorporate technology into making as a way to learn to work with items in the lab, such as our 3D printer, laser cutter, etc. But we start out with just basic crafting. One of my first projects is our microbit pet project, where students interview another student in the classroom on their ideal pet. Then one student has to build that ideal pet for the other student and incorporate the microbit with at least 4 interactive elements in it. We've got a couple examples here. We've got this little penguin and we have this little fish. So these 2 students were working together and one wanted a fish, one wanted a penguin. So the students went home with recycled materials and crafted up the bodies for their microbit pets. And then you can see we're including the microbit as the face of the fish, and we've got this interactive panel on the penguin here. So depending on button presses, different movements or positions of the microbit, we've got interactive elements that the students have programmed in here. So then the students actually present these to the class and demonstrate all of the utility that they have and walk the other students through their code. What's neat about the microbit is it can be expanded with other systems like this little robotic base. So this adds additional sensors such as ultrasonic sensor, light sensors, color detectors down here, as well as other outputs such as LEDs. The microbit simply plugs into the robot and dramatically increases the capability. So these are great. They not only can they program these directly through the computer, but you can even interface with these through Bluetooth and have code running on the computer in a block style coding such as MakeCode or Scratch interact with the robot, which is not tethered to the computer, which is pretty fantastic. I'm also exploring some microbit expansion packs now. So this kit is similar to something you might have seen with like an introduction to Arduino kit, where we've got breadboarding capabilities where you can connect different elements of electronic components such as servos, LEDs, motors, etc. And I want students to explore making cardboard robots with these. What's fantastic is this is all a very low cost way to get students thinking critically, getting them introduced to computer science concepts, and introduced to physical computing, which is a really engaging way to get students thinking and really using their minds.
Okay, this program is We Do 2.0, and it's a Lego based project kit. It comes with all of these pieces, and it is based on a computer, and it's a program on the computer that walks you through step by step building Legos. So it will take you on your first project. You say go, you start building, and it takes you just like any Lego program will, step by step through building the robot. There's an engine on here, not an engine, but a motor, really, just battery-based motor. And it just you can see, it takes you step by step. Here's what you do to build the robot. And add the motor. Good job. You go on like this, you connect the motor, and then there are programming modules. Every one of these squares represents a module, a routine. If you know anything about programming, it's a little subroutine that will flash colors. So this one flashes colors. You can pick which color it's going to flash. And then when you go like this, then it flashes the color. And so you start, this is the very basic program. If you go over here, you can see all the projects you can build. You can build a cooling fan, a moving satellite. Right now, I am in the middle of building a spy robot. And this is a science rover. So they have all of these projects to teach you to learn to use the different modules and to combine them. Very, very simple to very, very complex, and involves a lot of creativity on the part of students, because once you've mastered the basics by following their instructions, then you can figure out how to do your own and program it yourself. Okay?
Hey everybody, I'm back. Again, this is James Nance from A.D. Henderson University School and FAU High. And I'm here to talk about our drone program. So we participate in the Drones in School program, which is a nationwide competition for middle and high school students using first-person view drones. I absolutely love this program. We got involved last year, and it uses these small micro quads, which is really on the toy scale, with students who actually form a racing team from scratch. You can kind of think about forming an F1 team. Students are charged with developing a team identity, developing a team logo, team branding strategy, and besides racing and flying the drones, they have to create a marketing video, marketing poster, and team portfolio tracking their engineering efforts. Besides just flying the drone around, there are some STEM challenges as well. So each year they're charged with developing something to carry a payload. This year, they've got to carry these little foam puzzle pieces. Last year, they had to develop attachment to carry a little plastic poker chip like this. So students have to carry this chip throughout all of their races and capture the flag events and be able to produce it intact to the judge within 30 seconds of landing their drone, which is a pretty neat challenge. This allows me to incorporate CAD design and 3D printing concepts along with the engagement of flying the drone and developing this whole branding and marketing strategy. There are 3 ways to compete in this event. There's a simulator-only competition, which you see here using the Velocidrone flight simulators. So students can fly a different track all month long, and anyone from their team can log times on the track. The fastest times in the middle school and high school event earn points throughout the season. Then there's a new track each season as we go through November, December, January, February, and it concludes in March. A second way to compete is what they call the virtual competition. So we're actually given plans to set up a physical track in the half court of a basketball court, or we actually set ours up in the media center. We measure out the gates, and this course is the same for every other school competing across the country. So students log their times by recording in the DVR in their FPV headset, and they submit that footage of their fastest lap time on this track to the judges, along with their marketing display. Come with me. Similar to this, their marketing video and their team their team portfolio. So they're judged on the information presented here, how they work together as a team. Each member of the team has different job roles, from project manager to graphic designer to marketing manager, design engineer, manufacturing engineer, and drone technician. You'll notice none of those are actually pilot positions because anybody on the team can be the pilot. They also put together a marketing video to market their team and present that to the judges as well. Then they complete the course flying their drones, as well as have a capture the flag element where they hover over obstacles which will change color from red to blue to capture for their team. The third way to compete is actually to visit another school and have head-to-head races where you set up a similar track and in a 2-minute period try to get the fastest 3 consecutive laps with your team racing at the very same time as the other team or teams that you're competing against. If there are multiple teams or multiple schools, you simply run it as a bracket, just like you would maybe the March Madness in basketball. This has really been a fun and engaging platform to teach collaboration, critical thinking, teamwork, as well as STEM skills. I love the fact that there are so many opportunities to bring cross-curricular elements. I can collaborate with my language arts department, my arts department, as well as reinforce all the things that I'm trying to teach in STEM as well. Again, this is the Drones in School program. It is a nationwide program, and I would encourage any educator to have a look. We're using the Tiny Hawk 3 drones, which are pretty affordable. To get a headset, controller, and drone all together in a package only runs about $300. So you can get involved in this competition with a fairly low entry point. Thanks again for stopping by.
All right. Okay. Hi, my name is Dr. Ann Musgrove, and I'm here with Kelly Thomas. Kelly, tell us what you do for a living.
I am a STEM and computer science instructional facilitator with Broward County Public Schools. So we support K through 12 STEM, mostly teachers, but we do professional development and workshop for teachers. We go out to classrooms, we run competitions, write grants, do PLCs with teachers, all sorts of things like that.
Is there a favorite age group that you have?
Well, my specialty is elementary because
Okay.
prior to this position, I taught elementary school.
Okay.
And that's what my degree is in.
What type of robots do you like to use in the elementary school? Do you have favorites? Or?
I do. Dash is one of my favorites. He's sturdy.
Yes.
He or she is sturdy.
That's important.
And it's block coding that the kids are familiar with, and it looks very similar to what they do on code.org. So code.org is kind of that foundation that we use for a lot of the robotics, and then we move to the robot. It's an easy transition. So I like Dash. We just started working with Vex 123s.
We have those here too.
Yeah, the little puck robots. Those are great because they have the 3 different ways to code. The push button coding, the coding tiles, and then they have the Vex code on the computer. So we've been doing work with CS, Computer Science Inclusion, so it's important for us to find robots that have that are accessible to all of our students and have different ways to code. So I just got introduced to the Bebot, which I really like because it's just really easy push button coding. And that's great for our younger students, but also our older students, depending on where they're at. And even just there, it's accessible. You can actually press the button. It's not too difficult. What else do I like?
We use code.org in some of our pre-service education classes.
I am a code.org trainer for the Computer Science Fundamentals curriculum. So code.org has curriculum for K-5. And it's beyond the hour of code. It's basically 20 hours worth of curriculum that you can assign the students, track their progress, and it's really a great foundation. They have unplugged lessons that you can help to reinforce the computer science concepts. And code.org to me is always just the foundation, because
Right.
that's teaching the concepts. The students can kind of work at their pace. It's a controlled environment. It's not too overwhelming with too many blocks or too many options. So once they feel comfortable there, and they can take it to something like Dash, Bebot, Vex 123. We just got the Sphero Indies. I want to try that out.
We have Spiros here too. We have the original one that's like the size of a golf ball.
Yeah, so
kinda.
there's the Sphero Minis, the Sphero Bolts. There's a new Sphero Rover, and then that's for the older kids. But the Sphero, I'm interested to try out the Sphero Indie because they have these color cards, and the robot has a color sensor, and each color card has a different action. So maybe a red color means stop, and a green color means go. And you can even change the actions that each color has.
So you think maybe it's even simpler than block coding?
Definitely, yeah,
Okay.
because it's just a matter of setting down cards. But I like having a lot of different options, like just pressing arrows or using the coding tiles. I like having pre-reader options. So code.org has the pre-reader courses for kindergarten first.
Right.
So they're coding with arrows versus words. Instead of move north or move south, they have an arrow. So they don't have to read to do it. And that's nice for not just our elementary students, but any of our students who might have a language barrier or not reading or different reasons.
Right, right. So it's more inclusive for different
Exactly.
people to use it, or different kids to use it. So what advice would you have for an elementary school teacher who isn't specializing in robotics as far as maybe getting started with it?
Who is specializing?
Who isn't specializing? Just a regular old elementary school teacher.
I would say start with a code.org training.
Okay. all
That's
right.
that's step one, because that's going to introduce you to the main computer science concepts you want to teach your kids, great unplugged lessons to get them started, and that's sort of the foundation. And then from there you can introduce, depending on the grade level, Scratch Junior or Scratch. You might want a little bit of training for that, but you could also just have a kind of play around and learn on your own. That's the great thing about computer science too. And then just sort of, we offer a ton of trainings, but I'd start with code.org and then go from there. Like we have Boot Up curriculum, which is free, that uses Scratch and Scratch Junior. So just kind of taking a training here and there to build your knowledge.
Yeah.
And then you're going to want to build your library
Right.
of robots. So writing little grants along the way.
Yeah, that sounds wonderful.
Mm-hmm.
Well, thank you for coming, and maybe go play with some of the robots now.
All right, thank you.
Hi, this is Dr. Powers here, and today I'm going to show you the Dash robot. This is Dash, though I have named my Dash Rosie because we have another one over here, and we just want to make sure we give them different names because when we try to connect to them with our iPads, we have to see their name. If they both said Dash, it would be very confusing. So this is an educational robot that's great for K to 6 students, and we use them at FAU with our pre-service teacher educators a lot to teach them fun ways to integrate technology into the elementary classroom. And today I've got a little demonstration about how you could integrate this into a solar system lesson, and it's kind of about storytelling, about telling facts about the solar system, and also about measuring both with the metric system and with angles because the robot has to make turns. And so students and coding, of course. And we're using this app called Blockly, which is a lot like Scratch, to make a little program, which I've made one I'm going to show you right now. So let me press play and we can watch. Now it's very quiet, so so right there. What happened? It went the wrong way. So with robots, this can happen. So I'm going to go ahead and fix it. So I think what happened was we didn't put it in the right starting spot. So let me put it right here. I'm going to go to start. I'm going to press go. So there we go. There's Mercury. Driving to Venus. My robot is falling asleep. So anyway, Rosie is falling asleep on Venus right now. And let me see. Let's go. Connected to. I think my connection is But anyway, I'd have to put it back to the beginning, but you can kind of get the idea of how this robot works. Let's go check it out.
I'm right here. Send it to me. Whatever you do, you send it to me. You email it to me.
Good job, Rosie. Hopefully it doesn't stop here. There we go. In the sky. That must be the moon. Let's go there. It only goes in 10 centimeter increments, so you can't get it exactly. So kind of got silly with some facts about the solar system, or these are the inner planets in the solar system. Kind of doing a little story tree, kind of based it on the three bears, and we got to Earth and it was just right. So we found funny things about each planet and said, oh, it's too rocky, let's check out this one. Just trying to have a fun time. You can really integrate this in with any topic. So if you are doing something where maybe you have math problems that you want to solve, and you just put 1 through 10 on the floor, and the students are driving it to the correct answer, right? They can code the robot to drive in that direction. They're learning about centimeters, because when it goes forward or backward, it goes in centimeters. They're learning about angles, because when it turns, you can pick on the little dial how many degrees. They're also learning, obviously, coding. They can speak into the robot, so they can, do language arts. So it's a really fun tool. Hi, this is Dr. Powers here, and today I've got the Dash robot, and I'm going to show you how Dash can explore the solar system. So my Dash robot is named Rosie. You can see, maybe you can or cannot see his little flower on there. I put a sticker because we have another Dash robot over there. We don't want to confuse them. I have used the program Blockly, which is a lot like Scratch, to create a program that will have my robot navigate and explore the solar system. I'm going to watch you how it goes, or show you how it goes.
I think that's Mercury over there. Let's go check it out.
Good job. Nice job, Rosie. Rosie is the name of my Dash. Okay. About halfway, 3/4 way through our program.
There's no man up here. Okay, yes. This is the very making you turn it into Earth.
So what we did here is we just had Rosie explore the solar system, starting with the sun and going around saying different funny facts about the planets and just kind of retelling the story of the three bears, being a little poetic, and integrating social studies, planet facts, coming up with storytelling, creating a story. I did this together with some children. We did math, measuring in centimeters how far to go from one place to another. And we'd go into the app and actually choose how far in centimeters. So we have to measure that if we're going a certain distance, right? If we are turning, we will use this little interface where it's really friendly for young children because they don't have to necessarily know how to read the number. They can kind of see how many degrees it's going to be turning as well. So that's why it's a great K-6 educational robot. You can do just about anything with it. You can even record your own sounds like we did, which was fun, which is great for language arts and incorporating speaking into the curriculum, which a lot of people don't think of, that you could do, you know, they think of STEM and maybe sometimes STEAM, the art, and we even made this solar system here, but they don't think about, wow, reading, literacy, and STEM. So with this robot, you can do all those things. All right.
Hi, I'm Belinda Beckford, and I work for Broward County Schools. I'm an instructional facilitator for over 241 schools, and my programs include robotics, drones, AI, esports, Minecraft, and code. So today I have the VEX robot, which is for middle and high school, and we use this for competition, classroom, STEM labs, and also after-school clubs. Basically, the robot moves by control, and the students' goal is to pick up items and move around on what we have a field. So the controllers work the claws and up and down movement. And students put this robot together on their own and design it the way they want for each game.
Hi, my name's Kelly Thomas. I am here with the VEX 123 robot. This is geared toward first grade through probably fifth grade, but great for the younger kids. But I also have a teacher here that it also uses it with middle schoolers. So I'm going to show you why I like the VEX 123 so much. First of all, it comes with this great field, so your robot's not going to run off the table. I have a class kit right here, so there's additional tiles, and the kids can each group can have a field at their desk, and it's gridded so the students know how much one space is. The reason I like the VEX 123 so much is because there's 3 ways to code. First of all, you can code block-based coding on the computer. This is an online software. You don't even have to download anything. So all I do here is just like, I think my robot disconnected. Got to wake it up. So you just wake it up like that. I'll try to connect my robot, see if I can pair that. In the meantime, there it is. So it just works with Bluetooth. I can go ahead and pair it. And once it's connected, what's great is kids are familiar with this interface from scratch, code.org. I'll go ahead and connect. Oh, it looks like we're paired. Oh, we're paired already. I think we're paired. Let's see. I'll try again. If not, I'll show you the other ways it codes. It fell asleep on me. So once it connects soon enough, I'll let it sit for a minute, let it see if it wants to. It says connecting. The first way we teach the kids how to program is with the button coding. So you simply do 1, 2, 3. I hit go. 1, 2, 3. All right, so it can turn and do sounds as well. So that's great. Once they master the button coding, we can do the coding tiles. So they have a number of coding tiles. This I made up myself, but it's basically just to organize a bunch of different coding blocks that they have. They can do conditionals, sounds, all sorts of different things. Sensing even. So for example, for this one, I would just press these 2 buttons and think if I'm connected, if I'm connected, it's kind of hard to do all three at once. It's getting mad at me. But I think once this is connected, if I hit go here, it will run the code that's here. That's the idea. It might be still trying to connect over here. So, like I said, I like it because you can code with the coding tiles, you can code with the push button coding, and you can code online with the block-based coding. And that's the VEX 123.
Yeah, get off the camera.
Hey,
Hey! Hi, my name is Dr. Ann Musgrove. I'm an instructional technology professor at FAU, and I'm sitting here with James Nance, who I've had in how many classes?
More than one.
More than one. He's getting ready to graduate, aren't you?
That's it. Yeah, December 15th is my big day. I've got my cap and gown on order. Pretty excited.
A black dress?
Yeah, my black dress, my little black dress is all ordered. I'm going to be a big, pretty girl.
So tell us what you do for a living.
So I'm the STEM instructor at A.D. Henderson University School, which is the lab school.
I've heard of that.
Yeah, it's the lab school on the campus of FAU in Boca, which is also the home of FAU High.
Yeah.
So I'm not only the STEM instructor for the middle grades, but I'm also a club sponsor for middle and high school STEM clubs as well.
And one of the cool things about A.D. Henderson is that it is its own school district.
That's right. I'm afforded a lot of latitude to develop and design my own curriculum. And one of the missions of our school is that I disseminate the best practices and innovative curriculum with teachers across the state and across the country. It's kind of what I'm here to do today, is show off a little bit of what we do in the classroom and how I use hands-on learning to inspire students and kind of trick them into learning whenever I can.
You actually, your superintendent used to be the principal of my high school.
Oh yeah, Dr. Herbst.
Yeah.
A man with a vision, I'll tell you. He's
Yeah.
just a wonderful guy.
Yeah, he stole a lot of the good teachers from South Plantation. Actually, they were very happy to come and work with him in his own school district. I just think that's very cool.
I was actually a product of South Plantation High School. I was a paladin myself.
Ah, okay. Go winged mythical beast. Or,
Yes, a knight on horseback. Is
okay. I'm confusing with UCF. So what's your favorite thing to do in the classroom? What's your favorite stuff?
So,
or is there just too much to have a favorite?
There's a lot to list. So, as I mentioned before, I am a STEM instructor. Really, I was a science teacher for 10 years prior to really engaging in STEM education, especially full time. Now they have me just teaching STEM and not science, but I do feel that it's an advantage to have that background in science because I really understand the standards and benchmarks, and that really allows me to infuse those into my STEM curriculum as well. So I've got a varied course offering, and I try to change it up every year. So I've got an intro to STEM class where I do a little bit of intro to computer science through physical computing and the microbit. I demonstrated some of those projects earlier today. So that goes from simple block coding on a single board computer called a microbit, all the way up into robotics and physical computing applications. I teach an aerospace course, which teaches everything from the history of flight, and then ends up focusing on the drones in school program, which I'll like to talk about a little bit more. I do underwater robotics using the Office of Naval Research's competition, which is Sea Perch, where students build an underwater robot or an ROV, remotely operated vehicle, from a kit out of
And
PVC.
they play with them in the pool.
They do, yeah, absolutely. But it's teamwork based. They've got to write a technical paper. It's not all fun. They write a technical paper and outline their iterative design process. I teach students to follow the engineering design cycle from their very first class with me, from their intro to STEM, and I reinforce that through all of my courses. So they outline their steps in that iterative design process and the design of their ROV and the engineering stages that they went through to their final product. One of my favorite sayings is "fail early and fail often."
Yeah, absolutely.
Because we learn the most from our failure as long as we document it, right?
Yeah.
So I'm big on the engineering, keeping an engineering log as well. So that's a lot of fun. We scaffold that. That's a pathway program. We do underwater robotics in high school as well through a club called MATE, which is a more advanced underwater robot, where Sea Perch's line of sight, students are actually watching their robot from the surface at the edge of the pool and operating that through a tether. MATE, they have to operate it from a screen remotely. So it's much more real world, as if you're working on a research vessel or something like that. Much bigger robot. So
didn't you guys travel abroad this year?
Well, actually, we went to Denver this year for the
okay.
MATE competition, and we ended up 4th place in the world, and we actually got an award over all of the high schools and universities that were there, called the Sharkpedo Engineering Award for solving an engineering problem in the simplest way possible. So we had a buoyancy engine which took data readings in a column of water, and we made the whole thing out of a Nalgene bottle.
Nice.
Yeah, it was really nice to be recognized for that.
Was it the drone that you wanted to talk more
So
about?
yeah, so one of the new programs that I became involved with last year is called Drones in School. More information on that can be found at dronesinschool.com. But Drones in School is a fantastic program which teaches students about flying and racing drones, but it's a little bit more holistic than that. Imagine forming an F1 racing team from scratch. Students are charged with developing a brand identity, a logo, designing that logo, graphic, and turning it into a vector graphic. They've got to make a marketing display, marketing video, and then track all of their design efforts with an engineering log. While they're racing their drone, they have to carry a payload or a little chip. Last year it was a square poker chip. This year it's a foam puzzle piece. So in middle school, they need to design and manufacture an attachment to the drone which can carry this payload through their race, and then they need to present that payload to the judges within 30 seconds of landing their drone. So this
Is there an
allows
obstacle course of some
Yeah,
type?
so they're flying through gates, typically 5 gates and 2 slalom pins, and these are laid out in different ways depending on the race. Then there's also a capture the flag element. There are 10 beacons with an ultrasonic sensor on the top, and as you fly the drone over it, it changes color from red to blue. So in this event, rather than flying FPV or first-person view, which actually feels like you're sitting on the drone and flying, which is what they race through, they fly line of sight in the capture the flag, and 2 teams are head-to-head trying to capture the beacons for their color, either blue or red, in a 2-minute period, and then land. So whomever has the most beacons in their color at the end of that, of course, wins that race, as long as they can produce that chip to the judges. So there are actually 3 ways to compete in this. There's a simulator race where they race virtually on a flight simulator called Velocidrone. Students log into a certain track and fly with the Tiny Hawk drone, log their times throughout the month, and their fastest time goes up against all the other schools in the country who are also competing. Then there's a virtual option which is a lot more real world than it sounds. There's a universal time track, which is released each month, which we measure out either in a half a basketball court, or in our case, we use our media center a lot. We carefully measure those gates out, as do all the other schools participating across the country.
Got to be fair.
We got to be fair. Students record their flights through the DVR on their FPV goggles, and they send that footage off to the judges along with their marketing display, their team portfolio, and their marketing video. They earn points for each one of those, and there's a different event each month. Each month they earn points depending on their ranking, and which qualifies them for nationals. So we did get to go to nationals last year, which took place at the AUVSI convention, which is the Autonomous Systems Convention. So anything that can fly itself, drive itself, or float itself is there. So
where was that?
That was out in Denver,
Okay.
Colorado, which was really really exciting for the students, because not only did we have the racing and the interviews with the judges and the presentation of the marketing videos, they got to go around and you learn about careers and speak to professionals in the industry. It really opened a lot of eyes for these students. And this year we'll be traveling, if we qualify, to Purdue, and the race is going to take place concurrently with the collegiate drone race, national drone race as well.
Nice.
Yeah. So this is a fantastic program because it really allows me to infuse cross-curricular elements. I can collaborate with language arts teachers on their writing for their portfolio and for their marketing display. I can work with maybe the debate department or even the theater department for their marketing videos. And of course, I'm infusing those science standards anywhere I can when we talk about the physics of flight. Plus, we get to do all the fun stuff we do in STEM as far as CAD modeling, 3D printing, manufacturing with laser cutters, etc.
Yeah, I always said that, you know, if you're in technology, you get to play with everybody.
Absolutely.
Yeah.
I'm just a big kid with that still gets to play with my toys.
Yeah.
I just trick kids into coming along and learning something along the way.
I bet that they like you.
Well, you know, I'm not there to make any 12-year-old friends, so I do have to be the mean teacher sometimes.
Yeah.
But I like to design my courses the way I think a 12-year-old or 14-year-old me would like to be in that class.
Yeah. Well, thank you so much for coming and showing us all your cool toys today.
Thank you for having me. I really enjoyed it.
Yeah.
Hi, this is Little Bits, and what this is a kit to teach you about electronics and how they work. One of the things that you can do with this kit is, as you see, every piece is color-coded. It's also labeled with the direction that you need to use it. You simply snap them together, just like that, and then you can use them. This is our power source right now. So one of the experiments you can do is tell students to figure out what these pieces do based on their color. So for example, we have a piece with a little light. If I put it on here, it lights up, which tells you that this piece probably has to do something. I have a piece here that has a little buzzer on it, which is pink. And if I plug that in here, it sounds the buzzer. So that tells you the pink is probably something that you need to use to input. And so you can teach about input and output doing that. Other things that you can teach about are things like serial circuits, which would be stuff in a line, like this circuit to make the buzzer sound. Or parallel circuits, which is what this piece is for. It goes in here and then comes out here in different parallel lines. And you can also build things. Now this instruction book will go through everything for you, but it's nice to let the students just figure them out themselves and see what they can do. It also has some projects in the back so that you can actually try and put things together and see what you can come up with. So that's what I did. I started building this, and we need to use this piece, which lets me vary the kind of power that it uses. So we put that in here. I do have to tell you that sometimes it's don't snap in that well, so just be aware of that, because that can be a little frustrating. But once you get everything in here, I've got this set up because when I plug this in, whoa, there it goes. See, we just lost everything. But the other thing I could do with it is plug this in, and now my car has a horn. So you can have fun playing with it. Something else you can do is you can also use it to teach students about physics. There's plenty of pieces here that will let you do something like that. So for example, these pieces here, this one is a RGB light where you can adjust the red, green, and blue in the light. This piece you can use either as a counter or to measure the amount of power that's going through. Now watch this. If I plug this in, it just lights up and it tells me that there's 5 volts of power going through. But if I use this piece instead first, now I can vary the amount of power. But watch what happens to the light. As I go up, the light actually starts by turning red. Then it goes through green, and then it goes through blue. You just showed your students about electromagnetics, sorry, my tongue trips. And the fact that red light doesn't use as much energy as blue light. So besides playing, there's also all sorts of other things that you can teach your students. So I guess I can put this back together and try and run it again. Yeah, you have to kind of really press it in there. So let's get our piece here. This is what lets me control how much power the wheels have. And let's see, yep. Just doesn't want to quite fit in there. We'll plug in our horn. There we go. Something's not connected right. But that's part of the fun of it. Sometimes it doesn't always work quite right. So, you know, that's working. So this probably wasn't fully connected in there. Yeah. That's what I was afraid of. Yeah, you definitely want to play with these things yourself so you can find out what the issues are with working with them with others. And this definitely seems to be one of the issues. These just don't snap in that well. Let's try this again. Yeah, now it's working right. Until the wheel fell off. And there's your little car. I'll leave the rest for you to discover.
Hello, I'm Dr. Victoria Brown with the Department of Curriculum Instruction, and I'm one of the instructional technology faculty members there. And I'm here with Dr. Powers, who is also in the College of Education through the Curriculum and Instruction Department, and so my co-compatriot in the instructional technology faculty. So what we're going to do here today, as we come close to wrapping up our live streaming event, is that I'd like to share from an instructor or as a professor point of view. You've heard from students, you've heard from practitioners, and what does this mean for us in a bigger, wider scope kind of point of view of why is it important to teach robotics and why we're doing it here at FAU. So Dr. Powers has actually been working with robotics a lot longer than I have. So I'm going to kind of let her kind of start talking a little bit about why she found robotics important for our students here at FAU.
Well, first and foremost, robotics and coding and computational thinking and STEM in general is really such an essential skill. Countries around the world have made standards where they want to integrate these computer science skills, but also combined with different STEM skills into the curriculum, because these are the high-tech jobs. This is how we're inventing all of the new technologies and scientific discoveries of our world, and people need to be prepared to do that from a very early age. So if we can integrate educational robotics and coding into the early elementary classroom, children can start building the foundational skills that they need to be able to learn the more challenging things later on, so they have a foundation in it.
I was just writing actually a report on robotics and why is it important, and they were saying that 84 million jobs are going to be empty in the future just based on coding and robotics. So I was like, wow, that's an amazing job field that they can go into. And the other thing I found as you start to explore this a little more is that many, many jobs in the future are going to require you to know something about coding. And today, even in our homes, we have AI in our homes. We have to be able to talk to the AI. We have to be able to communicate with the AI in order to get the information that we want from that, whether it's AI or artificial intelligence or the future robots that we might be interacting with.
They are. We have been interacting with AI for much longer than we realize. So if we have Alexa, we have had AI in our home for over a decade.
That's right.
And we just didn't realize it. So surprise.
Our Apple phones. Hey, Alexa. Google.
Yes. So
yes.
That's taking a robot to the next step, so.
Right. Yeah, no, I think it's very important. So one of the other things I found, and it actually came from the aerospace industry, where I went to this big aerospace conference, and they were so excited that I was there as a person who teaches pre-service teachers. Mm-hmm. And one of the things they pointed out is that teachers are more comfortable teaching about animals and plants, and because they're so comfortable with that science field, we actually have many, many students who go into biology. And actually, biology programs are often the largest ones on campus because they're so interested. So it tells us that as early as kindergarten, that students are beginning to develop their career aspirations and what they might want to do. So it's very important for them to be exposed as early as kindergarten to the hard sciences, such as coding and
Yes.
robotics.
And this robot can be, it's so cute, first of all. You know, I feel like it's my little robotic pet. You know, I've named this robot Rosie. And you can do basically anything with it. So you can be doing a lesson reading a story. And you can integrate this into a language arts reading lesson where children are retelling the story. They can record different sequenced parts of the story, the beginning, the middle, the end, or something like that, and have the robot drive to the different parts. You can have the robot, as we did over here, drive around the solar system and say fun facts about planets. You can do just about anything. And while you're doing it, you're learning measurement, you're learning angles, you're learning coding, you're learning whatever subject. You could do something with history and have it go on a timeline and drive around. So it could really be integrated in any classroom. And if we can get our pre-service teachers to know how to use this fun tool, then they can be the ones out there showing children things that they wouldn't have been exposed to. Because, you know, I used to be a computer teacher, and not every school had a computer teacher. That was a special class, and only special schools even would have that. You might be getting that cut. You might only get PE and art.
Yeah.
So the regular classroom teacher needs to know how to use this. So that's why I included it in my class, and so did you.
Yeah, that's right.
So that we can show them how easy it is, and then they can show them in just any class at school. It doesn't have to be a STEM class.
That's one of the things I find really nice about the educational robots is that you really don't need to know how to code yourself. It's really visual with the drop and they have little
Block
procedural
coding.
Yeah, it's called block coding. The blocks have the procedures attached to them. And so it's more about the computational skills that you develop as you think about what do I want the robot to do? How do I break it into the smaller steps? Those are the computational skills that we're going to need, and we do need in our everyday life.
Yes, so they're thinking logically, they're designing programs, but they don't have to write the code. The code is written in blocks that are visual that they piece together, and they can customize them to do different things. So you could even, some of it's even visual where there might be a number, you're going to go 70 centimeters, but it also shows that the bar is getting taller. So even if the child is not reading numbers at that level yet, they can still get the idea as to how far their robot is going to move or how far it is going to turn. So, or what color it's going to be. It's going to show you the color that it's going to light up. So that's a really nice thing that they can even start doing it before they can read, but they can go even further, you know, if they can.
That's
So,
right. The other thing I find very impressive is the Little Bits talks about the creative cycle. And what I like is when you turn the Legos, like for example, over to the kids, they will enter the invention creative cycle within moments. So as soon as they figure out, oh, this is what this procedure does, what if I do this? And they start questioning, they start building their own problems to solve, and they start creating new robots almost immediately. And it's so quick, and it's so easy, and it's so intuitive to them. It's just amazing to watch happen.
Yes, they want to do it themselves. So
Yes, they do.
I recently went to Miami to an event it was a fair, it was a literacy and arts festival. We brought STEM into it, okay? And we had the routine for the robot ready to go, but I think I played that routine one time, and basically I was helping children. They wanted to drive the robot to this planet, and you know, everybody was coming up and taking a turn and coding the robot, and you know, coming up with their own challenge where they wanted it to go, what they wanted it to do.
Right, and that's exactly what they want us to teach. If society as a whole wants us to teach children to be creative problem solvers, and just by the pure exposure doesn't mean that you as a teacher need to be the expert by any means. I think we talked, I remember Nancy Rubin was here, and she said, just learn right alongside the kids. It's okay. They're going to love you for it. I think the other part of it that if people might be saying, wow, this is really great, I love all these little robots, but how am I going to integrate that into the curriculum? And so can you share a little more about how you see or envision these robots being integrated in the daily life of an elementary ed student?
Of the students. So the teacher could use this robot, for example, in one classroom, the children in first grade were reading The Very Hungry Caterpillar. And we know that's a story where they have the 4 life stages of the caterpillar's life cycle. So the children read the story with the teacher, then they did some art, they drew the 4 different life cycles, and we put them on the floor. And then, it was so simple just to, with the children, helping them program it to drive to the first one, the second one, the third one, record what it was, and then retell the whole story. So it's very simple. You could do that with any story that has a sequence. Another way is also peer teaching. So what you can do is once the children in the higher grades are more familiar with the robot, they can go to a class with younger students and work with them. So maybe the teacher is a little bit nervous. Well, these 5th grade students aren't. They don't mind helping that first grader with the robot. So you can have kind of like a little robot club or something like that. At one school, I work with a group called STEM Girls, and they actually do that. They go and they might be doing some math problems, and they put some numbers on the floor, and then whoever gets it right can like drive their robot to that number or something like that. They get to do it, or that kind of thing. They come up with fun little games where it involves them driving the robots to just do everyday things in the classroom.
I think what the interest we know just from the history of instructional technology, but the robot introduces a unique experience. And because it's unique, it allows the student to better remember and transfer the skills that they've learned. So yes, it might take a little bit of time in the school day to get your robot maybe to go and demonstrate the life cycle of the butterfly, but they're more likely to remember those 4 stages and more likely to be able to apply it or put it into a different kind of content area, which is what we really want as teachers. We want them to remember and transfer that knowledge. And I think that's where the robots come in, being in kind of additional unique experience. It helps them remember those things.
It does. And also for children who like different types of social interaction, some children might like interacting with a robot more than they do maybe interacting, with an adult so much. Maybe they're more shy around an adult and they don't want to talk as much, but they'll talk to the robot, that sort of thing. Or they just enjoy working with that and expressing themselves in that way. So.
I do think it does, and we haven't even talked about that here today, is what the robots can do for special needs children. So, and I think that's another field that we could, some special needs children, especially if they might have a learning disability, for example, might really struggle with writing or reading or mathematics. But here, when they can really pick up on the logical thinking skills that are really needed for robotics, and it allows them to excel and to demonstrate their knowledge in a different way than maybe they could in another setting. Or maybe it's an emotionally handicapped student, as you were talking about, who is shy and withdrawn, or maybe they're hyperactive, and this is a good way of channeling their hyperactive tendencies into a constructive project that they can be able to concentrate on and follow through with.
It's endless. The teacher can be creative. Maybe with ESOL students, we want to go around the room and drive to different things and say them in different languages so that everybody can hear. So I was talking to a teacher. She had students who spoke 10 different languages in her class. So maybe we can have the robot say that thing 10 different ways, and everybody can have a turn.
Right. Yeah. There's just so many. Again, I like to say it's up to the creativity of the teacher and the students, right? What can be done with the robots once we get them set up and get them started.
Yes.
So, is there anything else you'd like to share about robotics?
I just think that, they're wonderful. They're easy to use. Don't be afraid of them.
That's right.
Don't be afraid to fail. That's all about having a challenge and trying. And if first you don't succeed, try again.
Right.
And just have a lot of fun.
I think you have a really good point there, that it builds resiliency within the students to know that failure is not the end of the world.
Yeah.
You can definitely try something different. And I also like the fact that robotics actually integrates 3 different fields. If you think about it, it integrates electrical engineering, mechanical engineering, and computer science, all into one. So you're actually introducing them to 3 very large fields that need people in the future to be a part of them and be a part of that.
Yeah, and you can do it in a K-6
Yes,
classroom
in a K-6,
and
yes.
incorporate that to
In a very-
butterflies. So
I think you're right. Well, it's been a delight to have all the people here. I do want to thank all of the volunteers that have come in. Maybe, I don't know if you probably did not recognize, but many of the volunteers in the room were actually former instructional technology master students, or they're currently master students. One was even upcoming and was going to be a master student with us. And some of them are also in the doc program with the curriculum instruction with the specialization in instructional technology. So I'm very proud of all of our students and appreciate tremendously all the time that our volunteers have taken. And behind the scenes has been the Broward instructional technology team. And definitely need to give them a round of applause, please. They have done an amazing job. They've been following me around, or I've been following them around all day, and made sure that this went off well. I definitely appreciate all of that. And then I want to especially thank Linda Johnson, who is the vice provost of this particular campus, and her support for allowing us to work here and be a part and to do this event here. And also Dean Silverman, who paid for the video streaming so we could do this live with you. Also, I want to thank the Dr. David Kumar. This was his idea, and he also runs the STEM educational lab, and he's allowed us to partner with him in producing this particular event. So again, this event, I realize, want to share with everyone, it took 30 people to pull this event off today. So that means a lot to me, because I know it's my former students, it's my current students, and I feel like it's definitely showing that FAU can build a legacy in instructional technology in the region. So I'm so happy to be part of that. And Jillian, Dr. Powers was the one who motivated me, along with behind the scenes, Dr. Musgrove, to get involved in robotics. So I want to thank them for motivating me. Yes, they deserve a round of applause. Yes, in the room. So again, I want to repeat, if you are joining this for your class, I would like to make sure that you send me an email so you get credit. My email address is V as in Victoria, Brown as in color, 22 at fau.edu. We want to make sure you get credit if you're an FAU student for attending. And also, we'll be sending you an exit survey. So thank you again for attending and being with us and joining us here today.
thank you.